Welcome. In today's lesson on financial contracts for actuaries, we're going to look at zero coupon bonds. And our objective in this lesson is to define a zero coupon bond, to value zero coupon bond, and then to define a model contract for zero coupon bond. So that's a contract that will be suitable to run on the blockchain. Okay. Now, here's our definition. A zero coupon bond, informally, is a debt security that does not pay interest. A coupon, any interest will be called a coupon, but is issued at a discount, rendering profit at maturity when the bond is redeemed with full face value. Now, more formally, we may view a zero coupon bond as a value, ZCB, where par is the redemption price per unit nominal. So par could be 1, or if it's par is equal to 1, the coupon is said the zero coupon bond is said to be redeemed at par. If par is less than 1, it's said to be redeemed below par, and if it exceeds 1, it's said to be redeemed above par. Now, star is the commit date, so that's the date at which the investor commits to buying the bond. N is the redemption date, the date at which the bond is to be redeemed, and amount is the nominal amount. So it could be, say, 1 unit or 1,000 units, something like that. Whereas PPUN is the price per unit nominal. So, for example, if that we bought 100 units and the price per unit nominal is $10 per unit, then we would have 100 times 10, 1,000 pounds or whatever worth of the bond. That would be the face value of the bond. Now let's look at how to value zero coupon bond. Given a constant effective interest rate I, value of I of T of C is the value at time T of contract C. So by definition, the value of I of T of a zero coupon bond is equal to C times 1 plus I to the T minus N, where C is, of course, the amount times the par value times the price per unit nominal. For example, if we have an effective interest rate of 2%, then at time 10, the value of this zero coupon bond would be around, which is, that is to say, it has a start date of 10, it's going to be redeemed at 20, and it's 1 unit, the price per unit nominal is 1,000, it's redeemed at par, then the price would be about 820. So, now let's look at writing a contract for such a bond. In our contract, the investor wishes to buy 1 unit of a zero coupon bond with price per unit nominal of 1,000. At time 10, he commits the current value of the bond to the bond issuer, and at time 20, he wishes to redeem the bond at par. So, now, this is what his contract will look like. Okay? So that's the overall shape of the contract. So notice that here at time 10, this is when he must commit. If he doesn't commit at time 10, then there's going to be a refund. And first of all, the investor has to deposit £820 or 820 into that account. Okay, and that's, of course, what that looks like in Mono. Well, when this has happened, when this has happened, remember this was happened before time 10. Now when this has happened, or by time 10, then the money in the account is transferred to the bond issuer, and that's accomplished with this. So the bond issuer is paid 820 from the account. Now after this is the contract that should be executed. Now in this case, we wait for the issuer to deposit 1,000 into the investor account and to transfer the money in the account. So the way the investor would deposit that is, of course, by 1,000. Same thing, deposit account, issue 1,000, and then transfer the money from the account. Sorry, that should be transfer the money to the investor. That's a mistake. That should be paid Right, and it's got till time 20. So up until time 20, if at time 20 this doesn't happen, then there'll be a refund, and we'll look at that a bit more in a moment. And but up to time 20, so at time 20, the issuer will deposit 1,000, and then from the account it will be transferred to the investor. So that's what we hope to happen. So let's actually see this in action in the Marlowe playground. Okay, so now don't worry about this too much. This is just how to define the zero coupon bond, and then we have some, just to make things a bit clearer, we have the account, the issuer, and the investor values represent them. And so here is our main, this is where the action is. This is a function that will, from a ZCP, will create a contract. So here it does. It'll go when case. So the first thing is it wants to deposit the investor wants to deposit into their account the price. Now the price of the bond, of course, won't be 1,000. The price of the bond will be the value at time 10. And so we have here price equals value, there it is, given the interest rate at the start of the bond, and then that's our value function, which we saw earlier. And we have to, we can only put integers into bonds, into blockchain contracts at the moment. So we have to call the floor function to transfer from a floating point to integer. Okay, so this will deposit the price into the investor's account, then it will go to the contract buy then redeem. So we look, here's buy then redeem. Buy then redeem will pay into the issuer from the account the price, and then it will call on redeem. Yes, on redeem, when the issuer has deposited the face value, okay, because by this then it should be appreciated, we then redeem it, which of course is just paying from the account into the investor, the face value. Okay, so in this case we'll have 0.2% interest rate, and then that's our bond. Remembering we're redeeming a par, we purchase at time 10, we redeem at time 20, and we're getting 1 unit per 1,000 per unit nominal. And so when we compile this, just to see what this contract looks like, we will get pretty much what we've already seen. Okay, so we see that we're paying 820. Okay, and then we put 820 in the account, we pay the issuer 820, and then at redemption the issuer should pay us 1,000 to our account, and then we take the money. That's good. Let's come back to here. Of course, you can see that there's a problem. This contract has a significant drawback. Once the investor has deposited the 820, it will be immediately paid to the issuer. After that, two outcomes are possible. The issuer deposits 1,000 in the investor's account, so the depository there, and that is immediately paid to the investor in full. Yeah? That's what we hope to happen. But if the issuer, that should be the issuer, if the issuer doesn't make the deposit, then all the money in the contract is refunded. There's no money in the contract at this point, so the investor loses some money. So effectively the issuer could default, and in this case the investor is left nowhere. So how can we avoid this? Well, there are two ways. We could ask the issuer to deposit the full amount before the contract begins, but this would defeat the object of issuing the bond in the first place. So more realistically, we could ask a third party to guarantee the deal. If you like, almost like an underwriter who will pay us if the issuer defaults. But in order to do that, we have to learn about how to do escrow contracts, and we'll look at those in due course. So we have seen how to define and value a zero coupon bond. Moreover, we've seen how to implement this financial instrument as a Marlowe contract suitable for deployment on the blockchain. We have discussed the weaknesses of our contract and how they might be overcome. Okay, so for more information, you can look at, including source of the quotes I used, you can look at the Marlowe tutorial. There's the link. And until next time, take care.